Hello dear students, welcome you all. In this lecture, I am going to discuss about the proton-neutron theory. Proton-neutron theory of atomic nucleus. Right. So we have seen in the earlier lecture that the proton-electron theory of the atomic nucleus was discarded. It was rejected because of the several objections on it, right? But till 1920, this theory was dominant, right? This was the only theory that was capable of explaining various properties of atomic nucleus, although it has, several shortcomings, drawbacks, right? So in 1920, Ernest Rutherford suggested that electron cannot exist in free state inside the nucleus, but rather it exists in a bond state with proton, and then bond state is neutral. Although at that time Rutherford was not able to fully predict the existence of neutron, but he was speculating that free electron cannot exist inside the nucleus, but because there were a lot of objections we have seen in the real lecture, so he said that electron is bonded to the proton and there is a new state that exists, that is bond state, that exists inside the nucleus, and that state is fully neutral. So in that way he was able to explain some features of atomic nucleus. Later on, then several attempts were made to examine the structure of the nucleus. Various scattering experiments were performed. Ultimately in 1932, James Chadwick, who was a English physicist, right, ultimately confirmed the predictions of Ernest Rutherford, right, and he discovered a new particle and he gave that particle name neutron. Sorry. Now this new particle neutron was found to exist inside the nucleus along with protons, right? And it was in free state. I mean, it was not bounded as predicted by the Rutherford, but it was totally new independent particle that exists inside the nucleus, right? And several properties of the neutrons were also defined at that time, like it is a neutral particle, it is a particle that has half integral spin, right? So it is a fermion, obviously, right? It has mass of the order of 1.67 into 10 raised to power minus 27 kilogram, or if I express it in terms of AMU, then it is 1.00866 AMU, right? I will discuss AMU in the next coming lectures, right? So this was property. It was also found that this neutron has a non-zero magnetic dipole moment, right? So all these properties were assigned to the neutron, right? And it was supposed that now the nucleus consists of neutron and protons. The existence of the electron inside the nucleus was fully discarded, right? So now we have this theory. According to this theory, I'm showing you a picture. This theory is called proton-neutron theory of atomic nucleus, right? So according to this theory, what I told you, that the nucleus consists of proton and neutron, right, which are bonded together by strong nuclear forces, right? We will also discuss it in the coming lectures. So I'm showing you a image of the atomic nucleus. You can see it here, right? So you can see here, this is atomic nucleus, and this is the pic of atomic nucleus. You can see here, rather this is the image of the whole atom, and here it is atomic nucleus. So nucleus contain these green spheres are protons, whereas red are neutrons. So nucleus is a combination of arrangement of collection of protons and neutrons, whereas the electrons are revolving around the nucleus, right? So this is the new type of picture, new type of explanation of the atomic nucleus and atomic structure, right? The discovery of the neutron by James Chadwick completely changed the picture of the atom. Earlier, it was believed that the electron was present inside the nucleus, but now it is, demolished. This idea is scrapped, and we have a new particle, that is the neutron, right? So now I want to tell you that what happened to the objections that were raised against the proton electron theory, whether this new theory is capable of removing all those objections or not. First of all, now we know, according to proton electron theory, the atomic nucleus, it is represented as ZXA. Then according to this theory, the atomic nucleus contain A protons plus A minus Z electrons, right? And plus Z extra electrons revolve around the nucleus. This was a proton electron theory. Now according to proton neutron theory, right? The same thing, ZXA. Now according to this theory, it was proposed that the atomic nucleus contain total A nucleons. Nucleons means A is equal to the sum of protons plus neutrons. I mean, the nucleus contain Z protons plus A minus Z neutrons, and Z electrons are revolving around the nucleus. So now we can see, if I have an example of 7 nitrogen 14, then according to this theory, what is the scenario? The nucleus will have 7 protons plus 14 minus 7 neutrons. This is the picture of the nucleus, and 7 electrons are present outside the nucleus. So the total charge on the atom as a whole is 0, and it is neutral. But if in this case we have 14 proton plus 7 electrons plus 7 electrons here. So these are the two different pictures, but now we know very well that this picture is discarded. It is rejected, right? So we have now this picture is rejected. Now we have this picture that is more accepted according to the different principles of the physics, right? Proton neutron theory. So I told you about the different properties of the neutron. I forgot to tell you one more property, that is when the neutron exists outside the nucleus, it has a half-life period of around 15 minutes, and then after it decay according to the equation, neutron convert into proton plus electron plus anti-neutrino. We will discuss it in details in the coming lectures. So this is about the half-life period or stability of the neutron. Outside the nucleus, it is going to decay, right? So these are the properties. Now I am coming to the different objections that were raised against the proton electron theory. So now we will see whether all those objections are removed or not. So I am coming to the first objection, that was the objection of Bay mechanical consideration. That was Heisenberg uncertainty principle. Bay mechanical consideration. So we have seen that we have calculated the energy, right? So now let's calculate the energy again. Then in this case, we know we have calculated delta P. Delta P was nearly equal to h cut upon delta x. So it was around 5.527 7 into 10 raised to power minus 20, right, joule second per meter. Then we have calculated the energy, right? E is equal to P square C square plus m naught square C power 4, right? Now, this is the now one more thing that I told you here, that the mass of a neutron is this, right? Now the mass of neutron is, and mass of proton, right? I have written here 1.00866 AMU. Now I'm writing the mass of proton in terms of AMU. So I'm writing it. It is approximately 1.00727 AM atomic mass unit, AMU, right? So you can see here that the mass of proton is nearly same to the mass of a neutron, although the mass of neutron is slightly greater than mass of a proton. You can see here, but we can consider them equal. So we can say neutron and proton are same type of particle if we ignore the charge, right? So I was saying here in the wave mechanical consideration. So here this is the energy. Now this is the energy of a nucleon, whether it is neutron or proton. So when I put the value of momentum, that is this c square, m naught is the mass. We can take any of these two, and then c square. If we put all these values, now here you have seen that in the case of electron, because the mass of electron is very small as compared to the, it is very less as compared to the mass of proton or mass of neutron, right? So we have ignored this term at that time, but here now we can't ignore it, we have to put it. So when we will put all these value, you will get the value around 940 mega electron volt of energy. Now, this is the energy that a proton or neutron should possess, right, when it is present inside the nucleus. Now if we look at the rest energy of rest mass energy or rest energy of proton or neutron, right, nearly same because same mass, that is around 938 mega electron volt. So this is the rest mass energy of the either neutron or a proton. So this energy is slightly more than this energy. It means when the neutron or proton are present inside the nucleus, they will obviously have some kinetic energy, right? So their total energy will be greater than this rest energy 938. So it is justificable, it is acceptable, there is nothing wrong in it as per the rule of physics, laws of physics, right? It means proton or neutron, whatever we can say, they can exist inside the nucleus, there is no violation of the energy, right? Now I am coming to the I can recall the case of electron. When there was a last deviation, the total energy of the electron that must be there, that was around 10 mega electron volt, but the actual energy of the electron was 2 to 3 mega electron volt when it come out of the nucleus. So there was large difference. So that's why we ignored, we rejected the idea of existing of electron inside the nucleus. But here the two energies are very close, and this is acceptable. Now I am coming to the second. The second objection was related to the nuclear spin. We have seen that in the case of 7 nitrogen 14 that I have taken at that time, that according to this proton neutron theory, the total spin, as it is a even A, nuclei. So according to the experimental observations, it should have either zero or a integral spin. But we have seen that in case of proton electron theory, the nuclear spin of this nuclei was a half integral, right? But experimentally it was integral. So now look at this problem from the perspective of neutron proton theory. We know both neutron and proton are fermion. They have a half integral spin, and now the total number of particles inside the nucleus are 14. So obviously 7 proton and 7 neutron, all of them have a half integral spin. So the net spin of the nucleus will be integral, right? So it is fully in agreement with the experimental observations and the predictions that the even a nuclei will have either zero or integral spin. So now it is accepted. The objection was removed. Now I am coming to the third objection, that was related to the magnetic dipole moment. I have told you that the nuclear magnetic dipole moment is measured in a nuclear Bohr magneton, that is n is equal to E h cut upon 2m either p or mn. Now we know very well that the mass of these two particles are nearly same. So we can take either the mass of proton or either the mass of neutron. There is nothing going to happen, right? This result will nearly remain the same. Now the experimental observed magnetic dipole moment will be more close to this values, right? Whereas earlier here it was mass of electron. So we were saying that the and the mass of electron is very small as compared to the mass of proton or neutron. So this term should be very high, but in reality it was low. So that was the objection. So now this objection is removed because we have either neutron or proton inside the nucleus. Both have nearly same mass. It means the magnetic dipole moment will be now of the order of nuclear Bohr magnetons, right? So this objection is also dropped, right? And now we are going to accept the proton neutron theory, right? Then we have a finite size of nucleus. This was also objection. So now here we have total 14 nucleons. Nucleons means the particle that are present inside the nucleus. We don't have we are not having extra electron inside the nucleus. So the problem of the increasing of the size of the nucleus doesn't arise, right? So I was saying that now this problem of having extra electrons inside the nucleus is removed. So there is nothing going to happen when total A nucleons, that is 14 nucleons, are going to present inside the nucleus, right? There is no problem for the nuclear forces to handle these A nucleons, right? So this problem is also removed, right? Now I am coming to the last problem, that is with the wavelength. We have seen lambda is equal to h upon p. Now you can simply compare in the case of electron, right? Lambda electron will be equal to h upon, if I write is p is equal to mb for the simple consideration, and lambda neutron is equal to h upon here m electron and m neutron b. Now you can see mass of electron is very small as compared to mass of neutron. It means the wavelength of the neutron that should electron that should be there when it is inside the nucleus, it should be more than the wavelength of neutron, because its mass is mn is very large as compared to me. So when you will calculate the wavelength of the neutron associated with the neutron, if we treat it as a wave, then it will be not larger than the dimensions of the atomic nucleus, right? So there is no problem with having neutron inside the nucleus because it has high mass. So these equations are telling us that the wavelength of the neutron will be obviously less than the wavelength of electron, right? So these were the all objections that were raised against the proton electron theory. So the proton neutron theory removed all these objections, but now here the new problem arises. The problem that was the foundation of proton electron theory. The foundation of proton electron theory was beta decay, means electron or positron are coming out of atomic nucleus, right? So now if the electron do not exist inside the nucleus and neutron exist inside the nucleus instead of electron, then why the electrons are coming out from the atomic nuclei in beta decay process? So later on this problem was disposed by explaining that the electron do not pre-exist inside the nucleus, but they are formed due to the spontaneous conversion of a neutron into proton plus electron plus anti-neutrino associated with electron, or proton convert into neutron plus positron plus neutrino particle. So these are the two nuclear reactions that explain the emission of either electron or positron from the atomic nucleus. According to this theory, electron do not exist inside the nucleus, but they are formed when there is spontaneous conversion of neutron into proton or vice versa, right? And immediately after the formation, electron or positron and neutrinos, they escape from the atomic nucleus, right? So this is the explanation of the beta decay by the proton neutron theory. So now this theory is the most acceptable theory till today. We have the knowledge that the atomic nucleus contains proton and a neutron, right? So this is all about this theory. Thank you very much.